Hello everyone and welcome back to the fourth part of our Blender Geometry Notes Rubik Cubes Procedural Modeling series. In the first three parts, we built the complete logic of the Rubik's Cube step by step. We started by creating the cube structure procedurally using geometry nodes. Then we learned how to rotate one selected layer. After that, we introduced simulation nodes, stored rotation values, dynamically named attributes, and finally expanded the system so that all 6 sides of the Rubik's Cube can rotate correctly. So now the logic is working, but visually the Rubik's Cube still needs life. A real Rubik's Cube is not just about movement, it is also about the identity. Each face has a different color and those color helps us understand the puzzle state. Without colors, the cube may rotate correctly, but it does not yet feel like a real Rubik's Cube. This is what we are going to solve in this fourth part. In today's session, we will move from rotation logic to visual design. We will use geometry nodes to add color information to the faces of the cube. Instead of manually assigning materials face by face, we will do it procedurally. We will create a color attribute using stored name attribute. Then we will create a material in the shader editor and connect that material to our color attribute using an attribute node. After that, we will use index and compare nodes to identify each face of the cube and assign a different color to each face. This means every face color can be controlled by logic. Once the 6 colors are assigned, we will reconnect the colored cube back to our instancing system. Then our full Rubik's Cube will not only rotate correctly, but it will also look like a proper Rubik's Cube with different colored faces. This lesson is important because it shows another powerful side of geometry nodes. Geometry nodes is not only for creating shapes and movement, it also controls materials, colors, attributes, and visual appearance procedurally. For engineering students, this is a great example of data-driven design. For gamers and 3D artists, this is a practical example of how visual system can be controlled using logic. And for Blender learners, this is where the project starts looking polished and complete. By the end of this session, our Rubik's Cube will have 6 colored faces, working rotations, and a much more realistic visual appearance. So let us open the file from part 3, switch to material preview and start adding procedural colors and textures to our Rubik's Cube using geometry nodes. Let us launch Blender 5.1. Select this shortcut on the desktop and double click to launch Blender. I am running the latest version 5.1.2 and I am now going to continue by opening this 3_Rubik_cube.blend file. This was the file that we saved in our previous session. If you are continuing from the previous session, you can open this file and start working. But if you have come to this episode directly and if you want access to this file, then in the YouTube description or in the e-learning page, I have provided you a Patreon page link. Click on that link, go to the Patreon page, and from there you can download this file. I will now click on this file to open it. I will first come into my 3D view and I will change viewport shading to material preview. So I have enabled material preview because we are now going to work with materials. To create the material, I will come into my geometry nodes panel. I have my cube and temporarily I will disconnect this cube from my instances and I will directly connect it to the output. And you are seeing the output here. I will just zoom into this cube area, press Shift A, and in search, I am going to search for stored named attribute, which we had used before to store our variable. Add this node. I will click on float and I am going to change this to color. So the type of this variable is color. Instead of point, I am going to select face and then I am going to give it the name as COL. COL is the name of this variable. I want to create material. Before I continue, I want to save this file. So I will go into file, save as, and I am going to call this as 4_Rubik_cube cube, click on Save As. In this view, on the left hand side, you are seeing spreadsheet. If I click on this top left corner, I can change this particular panel into any other panel. Come into my general and I am going to change this to shader editor. By default, I have a material already added here, which is called as material. In this material name, I am going to call this as color material. COLORMAT. By default, you have principled BSDF shader. I doesn't want this side panel, so I will press N to close it. So you have principled BSDF and material output. I want the color of this material to be controlled by my variable that I have declared. I will middle mouse click and move it to the side. I will press Shift A and in search, I will search for the attribute node. In this shader editor, I will drag it and keep it here, and the color I am going to link it to the base color, and in the name I am going to give the same name that I used in stored attribute, COL. I am going to call this as COL. I have declared a stored name attribute called as color, and this variable I have attached it to the base color of my color mat material. Now, although the material has been created, we have not attached this material to any of our object. In this case, we are going to attach this material to our geometry using nodes. So if you come into geometry nodes panel, I will press Shift A and in search, I will call for set material node. So I will select this set material node and I am going to connect the cube output to this set material node, and the set material output, you can see it is connected to the group output. In the material, if I click, you have color mat material here. So I will select the color mat and immediately you can see that my cube turned black because as of now, the variable call has not been attached. Now I will take this stored name attribute and I will bring it in between cube and set material. So now whatever color you are seeing in the stored name material, you are seeing that color. In the stored name attribute, you have value color. I will click and say, for example, I select an orange color. And if I click outside, you can see that my entire cube turned orange. But in a Rubik cube, I does not want all the faces of my cube to have the same color. Different faces should have different colors. Here we are going to use this index numbering. Allot this particular color to a particular side of my cube. I will come into my geometry nodes panel, middle mouse click and pan it, press Shift A and in search, I will search for the index node. I will get the index node. I will again press Shift A and in search, I will search for my compare node and place it correctly, and in compare, instead of greater than, I will set it to equal, and here in the type of variable, I will click on float and I will change it to integer. You have only numbers. For A, I will connect index, and B, right now we set to 0. I will just drag and adjust it, and I will take this result and attach it to my selection. If I come into the 3D view, I will click on this move tool. If I middle mouse click and turn around, the bottom face of my cube is in the orange color. I am going to give different colors to different sides of my cube. I will make some space here. So I will move it to the side. I have stored name attributes equal index. I am going to repeat it 5 times. Select these 3 nodes. Store name attribute with shift press equals with shift press index. Press Shift D to duplicate and place it next here. If it doesn't get automatically connected, I will take this geometry and connect it here. and from the second stored name attribute I will connect it back to the geometry, and in the second case I am going to change the color to yellow. Now what is happening? The same face color is changing it to yellow, but if I change the B value here from 0 to 1, then you can see that one face is orange, and if I middle mouse click and turn, the other face with number 1 is yellow. See, 0 is orange and 1 is yellow. So I will just make some more room here. So I will select stored name material, equals and index. I select these three. I can delete this index and I can take one common index output for all this equal. So here again I will drag it and connect it to A here. So I will have one common index. I have connected to the first face 0, then face 1, then I will select equal with shift press stored name attribute, press shift D to duplicate, and I will place it next, and this time again I will take the output of the second stored name attribute and mark it to the input of the third. I will take the output here and connect it to the set material. In the set name attribute, I will click and I am going to select a green color. I will set the B value now to 2. I haven't connected the index here, so I will connect index to A, and immediately you can see side with number 2 is green. So I will make space, select store named attribute, with shift press select equal, press shift D, duplicate it, drag it and place it next. I will again disconnect this geometry and connect to this fourth stored name attribute, take the output and put it to geometry, and for the fourth one I will click here and I will select blue color. I will drag this index and attach this value to A, and I will set the B value now to 3. So now I have the 3 sides set to blue. Now again I will move the set material. I will select store named attribute with shift press select equal, press shift D to duplicate, drag it and place it next. I will disconnect this geometry and connect to this fifth stored name attribute. I will take this output and connect it to set material geometry, and here I will click and I will now select a white color. Selecting white, I am going to again drag my index and connect it to A, and for B I will set the value to 4. You can see that the side which has number 4 is appearing white. And finally I want one more color. I will move set material side. I will select stored name attribute with shift press select equal, press shift D to duplicate, keep it next, disconnect this geometry and connect to this sixth stored named attribute, take the output and connect it to the geometry, and now in the color, instead of white, we'll select a cyan color. In value here, for A, I will again set the index to A, and for B, I will set the value to 5. So now the side which has 5 is appearing with cyan color. So I have 6 colors on 6 sides of my cube. So now finally if I zoom out, I have the geometry out here. I will drag this geometry out and I will take the output from the simulation and connect it to the geometry out. Everything from this cube to all these 6 parameter and this set material. I will select this complete set here along with the index, and I am now going to drag it to the left. So I will just move it to the left, and after this set material, see whatever output is coming from this set material, I am going to drag it and put it to instance. So when I put it to instance and if I zoom out, you can now see that my entire Rubik cube is ready. So if I deselect and if you see it, see my Rubik cube is ready. I can come into the simulation and in Z axis I will rotate and see the rotation is happening correctly. I will rotate it by 8. Then along the Y axis I can rotate. Say I will rotate it here by 16. So I have a different rotation. Then in the third side index 2, I will rotate it by 24. So I have a different rotation here. For index 3, I will rotate it again by 8. So I have a different rotation here. This side index 4, I rotate it by 16. So I have a different index here. And in the last side index 5, I will rotate it by 32 and you have a different index here. So now my Rubik cube is perfectly working fine. I will reset all these values back to 0. So I will reset these values to 0. So when I reset it to 0, you have the solved Rubik cube. I want to add some amount of extrusion to all these cube blocks, and also I want the iterations whenever I am rotating and when I am manually setting these values to 8. I want to create a kind of iteration so that I can control these values. Instead of typing every time 8, how can I make it whenever I change the value, it should be a multiplier of 5. So we are going to achieve these two challenges in our next session. I will come to File and save it. So in the next session, we are going to add an extrusion to beautify our Rubik cube, and we are going to add a repeat iteration so that the rotations are always in the multiples of 8. Let us meet in our next session.